I'll quickly show about the payload that we have and the quadcopters that we have. And then I'll hand it over to Julius to deep dive more into Pix4D fields, how the data is processed, and some use cases. So thank you everyone for joining. So IdeaForge, most of you, I hope might be aware, but for those who do not know, I'll give a quick introduction. IdeaForge is India's largest UAV manufacturers with more than 50% market share. And we are also one of the oldest UAV players actually in the world. So we started more than 15 years ago, started by a founding team from IIT Bombay. And at that point, there was not a very large UAV players. So what that enabled us is we had to create an entirely vertically oriented company. So we are one of the few players in the world who make our own autopilots, right? And also we work a lot on our payloads. But there are some special payloads like we are going to talk about today, Multispectral, where we are integrating third-party payloads as well, right? About the company, we have well-known investors like Infosys, but now over the last 6 months, you might know that we have also been listed on the stock exchange, right? We supply drones to almost all Indian armed forces. And over the last 1 year, we are also looking at the North America market very seriously. So this is a bit about the company and our legacy and history. I'll quickly move forward. So quickly showing a portfolio of products. Currently, we are in the SUAS space, small unmanned systems, ranging from maximum takeoff weight of 2 kgs to 7 kgs. All of our drones are vertical takeoff and landing. The smallest one being Ninja and Rhino, which are under 2 kgs, going up to Switch, which is 7 kgs, which is a hybrid fixed wing VTOL, right? But today, we'll be talking about Q4i and Q6, on which we have integrated the multispectral parrot sensor. So just before we get to multispectral mapping, I wanted to also give a little bit of history of what we have played in drone mapping in India. Some of you might know that India is running one of the world's largest drone mapping programs called the Swamitwa program. So yeah. Okay, IdeaForge is Swamitwa program where we have supplied more than 300 drones. Or you'll have to remove your. Okay. I hope there is no. Great. So we have supplied drones for the Swamitwa program, where more than 600,000 villages in India are being mapped using our drones. Right. So this gives a bit of context into the number of missions that we are doing on a day-to-day basis. So IdeaForge has been, like I said, we are running. Our drones are being used across India, and we are also using our drones, specifically the ones you see on the slide right now is Q6 being used to map some of the highest mountain passes in the world, right? So when we give you this equipment, it has been tested in the harshest of conditions, and it can be used in a wide variety, right from the deserts of Rajasthan to the high mountains of Leh and Ladakh. So the same thing, and we talk about mapping, a lot of this will be happening in the forested areas or in hilly areas, right? So our equipment has been tested all across. This is just some more pictures from our recent testing where we had gone to Leh and Ladakh at sub-zero temperatures. So IdeaForge drones recently are also enabled for flying in valleys. So if you can, if you're mapping in hilly areas, forested areas, you can go to the top of the hill and fly the drone down from there. This was not possible earlier, but now this makes it very efficient to do polygons on both sides of the hill as well. I'll just skip over this part because it's more of the same and come to the meat of the matter for today. So multispectral imaging, a quick glance over here, what we are talking about. Julius will cover this, I hope, a little bit more in detail. But essentially, when we talk about multispectral mapping, I just wanted to present what we will be talking about is when we look at the entire spectrum of light with multispectral, we are looking at individual bands within the spectrum. And why we do that is because on the left, you see here, as per the health of the plant, the reflectance values in each of these bands changes, right? And by taking multispectral imagery, you can use indices to make NDVI or NDRE index and figure out whether the plant is healthy or stressed, and you can take action to improve it, or you can do analytics to identify which kind of plant it is, right? This is just to give context. And on this side, you will see the payload, the parrot sequoia, which is a 4-band, which will capture individual images that can be combined to form various indices. I won't spend much time here again because Julius will be covering this in much more detail. A little bit about the parrot sensor. It's a 4-band multispectral with one RGB camera. And it also has a sunlight sensor for calibrating according to the conditions, whether it's cloudy or it's sunny. It has an internal SD card slot, so all your images can be saved there. It also has its own standalone GPS and IMU, so the images that you get are all geotagged and can go directly into the Pix4D software. So now what we have done as IdeaForge is integrated this on 2 of our platforms. One is the Q4i, which has an endurance of 40 minutes and a range of 4 kilometers. We have tested it with this multispectral payload, and we can do more than 0.6 square kilometers in one flight. And you see the GSD values that you can expect with this, right? And the same with our flagship platform, which is Q6, which has 60 minutes endurance and 10 kilometers range. Here you have options also of a survey grade PPK enabled mapping camera, as well as daylight camera, thermal camera. So Q6 is actually one of IdeaForge's most versatile drones. And now we are also having multispectral on the same. So I think this is mostly about what the payload and UAV platform is, right? Using this, you will get the images. And with that, I really would like to thank everyone and hand over to Julius, who can dive a deeper into multispectral imagery, how we can use it, how do we process it, and get some good outcomes out of it. So over to you, Julius.
Yeah, thank you very much for the introduction. I'm very happy to be here and talk about our products and multispectral mapping. And maybe quickly, Pix4D is a Swiss company. We have over 10 years of experience in analyzing aerial imagery and especially with photogrammetry solutions. And we have solutions for different industries. And one industry where I'm responsible for is agriculture and the product Pix4D Fields. And that we develop in Germany. So I'm now sitting here in winter Germany with minus 10 degrees, but I have it warm. So I would say let's get started. So first, let's look a bit at the agenda for my presentation here. So at first, I want to give you a quick overview of what Pix4D Fields is, why it is unique. Then I talk a bit more detailed about multispectral mapping, so how in general it works and what can you expect for it. And then we go over a few different applications which you can do with Pix4D Fields. And in the end, we can have a Q&A session. Okay, so what is the most unique feature about Pix4D Fields? That it's offline. So it's a desktop software, and that allows you to also use it in internet denied locations. And that's especially important for agriculture, because in a lot of times you don't have internet connection, and also the data sets you acquire with those multispectral cameras can become very, very big. So it makes sense to actually process them locally at the edge. And for that, the workflow is pretty simple. So you set up your drone, you set up your area of interest, and the drone will acquire the images. That basically works the same for all the common drones on the market. Then the drone basically comes back, you extract the data. So in this case, for example, for the Parrot Sequoia camera, you would extract the SD card, put it into your laptop. Also, I have to note here the laptop or the computer doesn't have to be like a super beefy gamer computer. It can be just a conventional laptop and it would work quite well. And you can see it already here in the top animation that it's really fast. So we optimized the processing speed so that you get your results within minutes. So basically you can go to your field, map the field, the drone comes back, and 10 minutes later you have a a georeferenced high resolution map of your area, and you can start your agriculture analysis or directly sit together with your clients and look at the results. And that, I think, sets us apart from other software solutions. And we offer you all the tools to loop that to really do something with the data, like creating prescription maps for your machines and spray drones, but more on that later. Yeah, here you can see again this edge processing I talked about. So the software is able to crunch like really big data sets in a matter of minutes, and then the final result, which is an auto mosaic, or you can also call it an aerial map, is much smaller. So that then can be easier shared to other parties, analyzed, or also uploaded to some cloud system for further analysis. So processing all the data locally really makes sense and gives you quite an edge over solutions which rely fully on the cloud. Yeah, it's not just only about drone images and pics for the fields. So since some time, we now also added satellite data. So for all fields you basically create in pics for the fields, you also have access to satellite data, and that goes back over 6 years now. It's Sentinel satellite data, so the resolution is not as good, but you will see larger trends on your field. So you can, before you actually go out to the field and fly, you can actually see, okay, where are weak spots of I maybe plan a targeted drone mission, so it gives you much more confidence, so you get the most out of your drone flight time. But you can also use this data also to plan certain applications, for example, nitrogen fertilization, growth regulators, or fungicide. You can plan with satellite data if there's a cloud-free image. So just for convenience, the software is basically a hybrid approach. It allows you to utilize both data with the same tools, and that is also pretty unique. Yeah, here you can see a little comparison. So of course the satellite resolution is much lower. You see that here on the left side, so it gives you just a rough idea of the site. And then in comparison, of course, the drone mission is super high resolution, even better than Google Maps. So in most cases, you still would like to fly the drone. Yeah, talking about drone mapping, we already mentioned the Parrot Sequoia camera. So that is a pretty unique camera still on the market. First, it's quite affordable. Second, it covers all the boxes you need for multispectral mapping. So it has exactly the right bands in the ranges where you actually want to do vegetation analysis, like the red edge and the near infrared band. Also, it's combined with an RGB sensor, so you have both basically. So you have narrowband multispectral analysis for crop health, and you still have quite a good RGB sensor if you, for example, want to do something like weed detection or measuring your field boundaries or do a damage detection after a storm. So it is a very good package. And one really special thing about that camera, and that makes it also very unique on the market, is that it is radiometrically calibrated from the factory. So with this camera, you actually have a targetless workflow. So if you look around with other multispectral cameras, you always have this little basically sheet which you need to put somewhere on your field and then make a photo of it. And that is used for radiometric calibration. And Pix4D Fields does this for all the other cameras if you have such a reflectance target. But with the Parrot Sequoia Plus camera, you don't need that because the camera is so well calibrated that we don't actually need to always put this kind of reflectance material. And that is a big advantage because it saves time, and also like, yeah, you can forget this sheet and then your data is not as good as you would like to have. And with the Sequoia Plus camera, that is pretty unique. Okay, so multispectral mapping, like was introduced in the previous talk, it's basically about the electromagnetic spectrum of the light. And to sense properties of vegetation, there are some interesting bands you want to look at, and that is red edge, and NIR. And you can see in this graph here, the green line, for example, that would be a normal healthy leaf. And you can see it has a really distinctive signature. So it consumes a lot of red light. So that's why it reflects less light. And then it reflects a lot of NIR light. And on the opposite, you can see, for example, the soil that has a pretty, constant reflectance across the board. And this kind of property we use to distinguish between healthy vegetation, stressed vegetation, and even soil. Here you can see it in a bit more detail, like how the different bands reflect for certain objects. So for example, the healthy plants, it reflects basically all of the near infrared light, but it consumes most of the red light. That's why, that's why it's healthy. It basically uses the red light for photosynthesis. And also that's why it's green, because it cannot use green light. That's why plants are green. With the stressed plant on the opposite, it cannot consume so much red light for photosynthesis because it's stressed, right? The chlorophyll is diminished, maybe doesn't have enough fertilizer, or it has a disease. So that's why it's not able to capture so much red light. And as a soil, you also see that it's pretty distinct from stressed plant and healthy plant. So, and with that information, we can now construct something which is called a vegetation index. So they basically work all the same. So there are two really dominant one. The one most used is the NDVI. That's a normalized difference vegetation index, and the NDRE. So those are the most common ones, and definitely the ones you should start looking into if you start with multispectral sensing. And what we do here, it's just a basic formula you can see here on the left side, and we just compare the reflected NIR and red light, and then we normalize that. So the NDVI, for example, has a scale which ranges from -1 to +1. So on everything under, for example, 0.2 or 0.3 would be very low vegetation or even soil. Then everything from 0.3 to 0.6 is like moderately healthy vegetation, or vegetation where the canopy is not fully closed. And everything which goes closer to 1 is really strong, vigorous vegetation. Yeah, and that is basically how you convert the images into actionable information with those kind of vegetation indices. And that's why it's also important you have a multispectral camera which is radiometrically calibrated, because if you don't do a radiometrically calibration correction of the camera with the sunlight sensor and with the panel, but for the Sequoia, as I said, you don't need the panel, the values the camera measures can be different based on the sunlight conditions, or based on like the atmospherical conditions. And the radiometrically calibration Pix4D fields does with multispectral cameras is to remove all those effects, so that the value you get always means, okay, this is this kind of healthy vegetation. Yeah, if you don't have that, and for example use an RGB camera, values can mean totally different things. So it makes it really hard to compare data sets over time, do trend analysis. So you need to be really careful. So that's why multispectral camera and radiometric correction is really important to do really sophisticated crop health analysis. Okay, so that is now the basics. So we covered like what multispectral mapping is. So we can now fly the drone, map our fields with this camera. And now, of course, we want to do something with the data. Now I want to touch a bit on the things we can do with the software Pix4D fields, aside from the really quick processing. So one really important topic for agriculture is field boundaries and obstacles. So in Pix4D fields, field boundaries and obstacles are used for two things. So first, of course, is to basically limit the outline of your field, and also designate certain areas for example, for agricultural machines where they should not apply or should not fly through. So that is especially important for spray drones. So with Pix4D fields, you can create those boundaries based on your high resolution drone data, and also like, for example, if there's a tree or power line, you assign it an obstacle, and then if you have a compatible agricultural machine like a tractor or spray drone, it will recognize those and drive or fly around it. On the other side, we use those boundaries to limit the area of interest area. So we basically trim all the data to the outline of the fields. And why is that important? You can see that here on the next slide. So on the left, you can see an untrimmed data set. So that is a whole scene. It has roads on the side. There's an agricultural farm also on the side, different kinds of crops. So it's all intermixed, and you can see the layer, it doesn't tell you so much because, yeah, it has a really high range. So the actual field area, there's not enough contrast, and you can really see which areas are stressed and which are not. On the right side, we trimmed the layer to the actual extent of the field. And here you can see quite clearly, okay, where are problematic areas, where I need to do, for example, a targeted scouting. So it's also one thing with multispectral mapping. It those vegetation indices, they show you where is stressed vegetation, where is open ground, where may be some deficiencies in irrigation. So that is all possible. But the real cause of the problem, you have to find out with scouting or with experience over time. So you use this data, and then you would go to those areas in the field and inspect what kind of disease is it. Is it something waterlogged in the soil? Is it animal damage? Is it some kind of fungus infection? And when you know that, then you can basically go to the next step. Then we go to something which is called variable rate application. So that would then transfer the visual information we have, and we ground truth basically, and move that to a machine readable information. So here again, you can see how you can create vegetation indexes in Pix4D fields. So we have a lot of indices pre-configured, so you just select them from the list. But if you're interested into really like hardcore research and want to use state-of-the-art indices, we have a complete index calculator where you can combine the formulas as you see fit. And that can be, for example, very beneficial for field trials, for crop breeders who want to try certain things, which you can see here. So that is a research trial where we, for example, calculated the EVI index, and with the custom index calculator, you can do all that. So that is now the theory. So how does a practical analysis look like? So again, we start with a multispectral aerial map, or we will call it multispectral automosaic. Then we will trim it to the field extent, and we will calculate the vegetation index, for example, the NDVI. Then we find out what the issue is. For example, this here is a canola field, and I know that it comes out of the winter, and then some of the plants are stressed from the snow. So we know that is basically this issue. So now I would say, okay, those areas which are underdeveloped, we would fertilize a bit more, and the areas which are good developed, we would fertilize a bit less. So, and how do we do that? That is a feature which we call the zonation tool that basically ingests the vegetation index layer and simplifies it into distinct zones, like 3 zones, 5 zones, depends on what the user wants, and also what kind of technology he has on a farm. Has he a spreader which can work really fine? Has he a spray drone? So all that can be adjusted with our tools. And then you basically can simplify this vegetation index layer, and you get, for example, 3 zones. You can see it here. So we simplify it. We have a red zone, which would reflect poor growth, yellow zone, which would reflect average growth, and the green zone, which would reflect exceptional growth. And if you want to do now a nitrogen fertilization, for example, you can do it pretty easily. So you just sit down and plan the nitrogen application rate for your whole field. So based on what kind of average yield you expect, and usually your management for that crop. And when you have that value for the whole field, you just set this for the yellow zone here, yeah, because that's the average of the field. So you planned, for example, okay, I need to fertilize now 100 kilograms of nitrogen per hectare. You set it to the yellow zone, and then you need to make a decision. Does it make sense to improve poor areas, like in this case? So I would here in this case say, okay, the red zone, which is poor growth, I would fertilize a bit more. So for example, I would give like 125 kilos in that zone. And the green zone, I know, okay, that came really well out of winter. It still has a lot of nitrogen in the soil. So I go a bit down there. But it also can be completely the opposite for a different crop. So for example, if you have a winter wheat crop in the late season, where you actually want to increase the protein content of the grain, so you get a higher pay for your produce, you would say, okay, the weak areas I fertilize less because it's already ripe basically, and the good areas I fertilize more, so I can generate crop with more protein content. So that is really crop specific, and basically it involves agronomic knowledge to create the right map for each crop. But with the vegetation index data, you actually can adjust the distribution of your input. Yeah, and that's what we call variable rate. Yeah, so variable rate just basically means the right amount at the right time at the right place. And of course, for every crop, every farm, it can be different, but across the board, you can slightly increase your yields. Of course, you can save a fertilizer. What may be even a bigger impact is that your crop can become more homogeneous. And that means it ripes evenly, and also harvesting conditions are much better. And harvesting usually also is very costly. So being able to harvest your fields faster because there's less lodging, the crop is really homogeneous, so the combine can drive on the same speed for the whole time has actually a really big impact. Variable rate can not only be used for fertilization, you can also use it for crop growth regulators. So that's pretty easy. Where the crop is really strong, you put less. Where it's really you put more. So where the crop grows strong, of course, you need more growth regulators, and where it's grows weak, you can completely save on growth regulators because you would just decrease yield if you also put growth regulators there. And for fungicides, it's basically the same. You can also adjust fungicide rates based on the biomass. So that's what we call variable rate applications. And Pix40 allows you to put out those maps for different kinds of machines. So for tractors, for spray drones, we have different formats for different kinds of tractors. So we try to ensure that it's compatible with all kind of agriculture machines. And if you don't have such a machine, you can also just use the map, create a PDF report out of it, or use our share to cloud and share it to your phone, and then basically go by foot. For example, if you have an orchard and want to identify trees which are unhealthy, you can also do that with your phone and just do then a manual application based on the map. So you don't need like super expensive machinery to get started with remote sensing. Even in very labor intensive conditions on small farms, it can be very helpful to just have the data and know, okay, which part of the field needs to be treated differently. Okay, now comes a topic which I find very interesting, and that's weed detection and spot spraying. In Pix40, we have a tool which is called the magic tool. And the magic tool is basically a classification algorithm. And that algorithm allows you to detect all kinds of anomalies. It can be weeds, it can be damages from wild animals, it can be storm damage, it can be waterlogging, you name it, because you train it. It also runs locally, so no upload in the cloud. And as you see here in those screenshots, it runs live. Yeah, so you click, you give it a few examples, and it would learn instantly for your field. And that makes it a really, really powerful tool for all kinds of crops on the whole world. And you can see here an example. That's something I did this year in Germany. So here we also did some green on brown detection. So we used the magic tool to actually detect the green spots after a harvest of a wheat field. Then we created a prescription map. You can see that on the right side. That is a map with the red annotations. And then we sent that directly from Pix40 to this John Deere tractor and Amazonas sprayer. And then the tractor only applied herbicide where it actually was needed. And that can result in huge savings of up to 90%. And we commonly see 50, 60% of our customers saving inputs with this technology. So especially for herbicide application, it is, I think, clear for everybody that you only need to apply the herbicide where actually weed is. And if you have a tool allowing you to identify the weeds and then do a targeted application, you save a lot of money. You can also increase your crop yield because you don't hit your crop with herbicide, where it doesn't need, and also you save your soil productivity because you lessen those aggressive chemicals and also increase water quality. So that is one of the very few use cases which is actually a win-win for the farmer, for the society. So that's why everybody likes to do it. And here's another example on a Greenland where we actually detected like an invasive species we have here in Germany, and the animals don't like to eat it. You can see those brownish areas, and we identified that also with the magic tool. And then we used the spray drone to actually targetedly apply herbicide. And of course, yeah, that saves a lot of money and also increases the grazing quality. So just to give you a few ideas what actually can be done with the tool. Yeah, here are two testimonials from customer. I have here one customer from Spain who also used the magic tool to save over 50% of inputs. Then we have here also a customer from the Czech Republic who used it to decrease herbicide use. And yeah, now in the next year, I think a lot of people will basically do spot spraying because it's now really easy. For example, with a software like Pix for the Fields to use because it's fast. You don't need a computer science degree. It's basically a bit like a little game. Yeah, so it's also really fun to use the tool. Yeah, here's another example from Argentina where they saved actually 66% in a winter wheat field where they identified some kind of grass weeds. So yeah, it's very valuable for the farmer and also for the service provider to offer this service based on drone images. Okay, I'm slowly coming to the end of my presentation. So one last thing I want to talk about is general reporting functionalities of the software. So the software comes with a lot of tools to do annotations, so you can do points, measurements, and lines. And we also give you the crop health data for those elements. So if you drop a point, you can see what the vegetation index at that point is. If you draw like an area, we will basically show you the average vegetation index of that area. And as you see in this example, that is a field trial. So you can easily assess, for example, different treatments. If you, for example, try different crop varieties, you can map them with your drone, then draw an annotation over the two different varieties, and then you compare them actually with factual data. And that is super helpful for research. And also, if you have like a client and you need to do a documentation of your project, and the client doesn't have Pix for the Fields, you can just create a comprehensive PDF report, which basically allows you to do a full replication of your Pix for the project based on a printed report with all the information you also have inside the software. Besides that, we also, I mentioned briefly, have a tool which is called Share to Cloud. So you can also share your data to the Pix4D cloud, and then you get a link back, and that link you can send via WhatsApp or any kind of messenger, and then people can see the live map and explore it on their mobile device without the need for any software. So it is a really flexible tool and basically accommodates you in all kind of situations. Okay, and finally, I just want to announce that next week we will have a big release of the next version of Pix for the Fields, which is Pix for the Fields 2.5, and that comes with very good new features. So I showed it briefly, the new zonation tool, which gives you full flexible to create your prescription maps for your agricultural machines. We integrated with John Deere, so for users who use John Deere machines, they can directly upload data from Pix for the Fields to a John Deere tractor for application. And we also integrated a format called ISO XML, that's specific format also for tractor terminals, and a lot of other minor features. So yeah, we are really excited to release that next week, and that will basically give you the right tools for the next growing season. Okay, so I'm now at the end of my presentation. So if you after this presentation want to reach out to us, I think the best contact is Mito Aurora from us because he's a business developer. He's also located in India. And yeah, he can basically solve all your needs and get you in touch with me if there are any like more advanced questions about our products and software. So that's the end of my presentation. I thank you very much for your patience. And now I think it's time for questions.
Thank you, Julius. It was a great presentation, I guess, in the afternoon or early evening, I would say, right, for the Friday. We have got a couple of questions from our participants. I would request if there are more questions people who would want to ask, they can put it in the chat box, right? To start with, we have a participant who has asked, how can someone get the defects annotated, even if the person is not a subject matter expert? So, Julius, if you would want to take this up.
Yeah, that is a good question. Of course, like you can, so what you can, when you map with a drone, you usually can see what kind of damage is. Yeah, so for example, if it's a storm damage, waterlogging, that is easy also for a non-subject matter expert to identify. But on the other side, for like what kind of pests, what kind of infections the plant has, you need to be a subject matter expert. So usually how service providers who come from the drone space are doing it is they map the field.
Julius, you went on mute. Sorry.
Oh yeah, I went on mute. Sorry. Yeah, where did I left? Yeah, so if you are not a subject matter expert, so simple things you can easily detect and annotate with the magic tool, like storm damage, water logging, low emergence, that you will easily see also as a non-subject matter expert, and the magic tool will basically allow you to annotate it and also give you the area of it. For more sophisticated agronomic analysis, yeah, you need a subject matter expert. So people from the drone industry, how they usually do it, if they are non-subject matter experts, they map the field, create a vegetation index, then creates this kind of zonation I showed you to partition the field in 3 zones, like medium, good, and bad. And then they hand this over and talk with it with the farmer. And then the farmer, with his experience, can quite quickly assess, okay, that is the area. Oh, it's that big on the field. Okay, now we need to act. And then you can create, for example, prescription map for him. That is how I would go about it if I'm not a subject matter expert.
Oh, yeah. Great. So I guess I would try to now zoom out a little bit, because basis that question. We have been talking about, I would say, multispectral and its applications, right? And it has been dominantly focused on agri research, right? So there have been a lot of questions which people have asked, and where they were curious to know where all they can apply multispectral camera, right? Is it just agriculture? Is just the research? If Pradeep or I would say Julius, if you can spend some time and give a little idea in terms of where this, what are the broad applications and where it could be used?
Yeah, I would say not at all. So I think we are far beyond just using it for research and just generating some kind of numbers for statistical analysis. So I think the software is now so easy to use, it's so fast, and the tools are, especially in Pix4D, it's very practical focused. So we really made sure that you can convert those vegetation index maps into machine readable data. So you can really push it to tractors, to spray drones, or even give it to somebody who goes then with the phone. And if he has a backpack sprayer, you can also adjust the spray rate based on the map. So it can be used for a wide range of application in practical agriculture. Of course, the first thing which comes to mind is digital scouting. Yeah, so of course you map the field and you want to find out, okay, what anomalies are in the field, how big they are, and what it is, and that gives you a really big advantage. Yeah, so for example, you can early spot disease when they are just starting, because in the vegetation index data you will get an early signal of stress already. So you will see those patterns in the field, or if, like, for example, there's an insect infestation which comes usually from the edges of the field, you will see that instantly in the multispectral data, that there is some kind of stuff going on. Then you go there, you see, okay, it's this insect, I need to act. So that, I think, is the first thing to do. And then all what I talked about, very elaborate application, identification of weeds. So that is all really practical, and that can save you a lot of input, increase your crop quality and your yield. So there are many different things you can do. Or also, if there's, for example, a situation where there's a damage. So often in practical agriculture, it happens that you have a neighbor and he does some kind of spraying with a pesticide, and then there's a wind and it drives all to your field, and then you have a lot of damage. With the drone and the multispectral drone, you just fly your field, and then you can easily see those patterns, know exactly what kind of area is affected, and then come with a really factual report to settle those issues. So the areas of applications are basically endless. What you need is, of course, some agricultural experience so you can relate, so you can basically think, okay, I have those problems in my crop here. And if you know enough about the drone sensing, you instantly know, oh, the drone can help me to actually find and treat it. So yeah, that's still something you need, but the practical applications are there for sure.
Okay, thanks. I guess this was quite detailed. I guess we have a couple of participants who hands. I would request them to put their questions in chat, and we will pick it up after one, because we have some more time. If you have very specific question, Rohit, then I guess there was one more participant who had raised a voice. If you can put it on chat. Yeah. So there is one question which is around machine learning and data analytics, in terms of how that could be uh, used in the implementation in context to our the maps.
I mean, if it's about machine learning in general, so then I would say Pix4D software is really good to create the high quality data you need to start the machine learning. You can also label basically the data with the annotation tools, then export the high resolution image data. So you can export it as GeoTIFF in all industry standard formats and feed that into a data analytics pipeline. For example, if you want to build your own machine learning models in Python, Pix4D software will basically generate your high quality image data that you can use to train those models. Of course, we try on our own to add those models over time, like the magic tools. It was our first approach. And we probably will also go in the next years into more sophisticated things like counting plants, stand counts, and things like that. But yeah, that would be my answer for that question.
Okay. So I guess there is a question which is related to the tree counting. Is it possible to identify whitefly infestation in coconut trees using multispectral imaging?
Yeah, that comes
And
back to agronomic knowledge, which I don't have for coconut trees and this specific disease. So what I would say is, if this insect damages the tree, then you will see that in the multispectral data. So you will see some kind of anomaly in the tree, especially if you have flown when the tree was healthy and then flew multiple times to the season during the season. You will see that, for example, the NDVI gets lower, or you will see some kind of patterns in the images. That could be an indication that there's an infestation. Of course, it will not pop up and say, okay, this is whitefly infestation. So you need still some kind of street smartness to then do something with the data. But if the crop is stressed, you will definitely see it.
okay, sure. So I guess we have a question which is around, I guess this is for Pradeep. This is for, it says commercial uses of the multispectral payload on UAV and how helpful it would be for the research purposes. So if you can maybe give some idea to the user in terms of what are the commercial uses of the multispectral payload.
Yeah, so commercial use, I am not sure 100% what you mean. For example, if you are a service provider, of course, you can just offer multispectral data, for example, to crop breeders, to research institutes, to governments. I think there are a lot of different opportunities where people actually would like to have the data, and maybe also some part of the analyzers. For example, if you say, hey, I digitize your field trial and I give you an Excel sheet with per plot the average index values of the NDVI. I think that's something you can really sell, because usually people don't want to venture into that so deep. And with Pix4D fields, you can easily create that. Or even if there is like damage, there was a big storm event or something, and you can do like those assessments of the damages and sell the reports. So I would say, yeah, that's our options to sell multispectral data. Of course, the more you analyze on top of it, like creating the maps for the farmers for their tractors, identifying the weeds, of course, those kind of things are much more valuable than the raw data itself.
Okay.
Yeah, I think beyond that, even for forest departments, right, they are also interested in mapping, and especially multispectral mapping would be quite important for them. We know of forest departments that they have to do at least twice in a year surveys to check what is the plantation monitoring. So they have certain funds for afforestation programs, and they have whatever plantation they have done using those funds, they have to give back a report, right? So along with just the count of the trees and if they're in good health or not, if you can provide a multispectral map, I think that is something that, you know, once you have this payload with you, you can give those services, and obviously you can charge much more than normal RGB mapping, and, you know, get a good return on your investment. I see also another question around, can we use it for power line and power tower inspection? Not directly, I think. I don't know, Julius could add here, but I do know that power line inspection is a very big use case where you have what is called the ingress of vegetation for power lines, right? So combined with some kind of LiDAR, which actually gives you those power lines, you could have a multispectral map and potentially predict which areas are, you could say, vulnerable to infestation by vegetation, right? And in that case, you can then make a map that this is the problem area, and the trimming team can go there and do the advanced trimming so that the power lines do not get disrupted. So these are some, I think, beyond agri, some use cases that could be that are actually already in use and upcoming in India, right? As we get this thing more out in the field, customers are obviously asking for multispectral imaging, but a lot of subject matter expertise and let's say subject matter experts will have to get involved in the interpretation of the data, whether it's for agri or forest or power lines, so that element has to be there. Back to you, Mo.
Maybe one comment for towards that. I mean, there are, I think, also industry-specific solutions for this kind of thing, like inspection of infrastructure, power lines. So Pix4D is also doing software for that. I'm not responsible for it, but for example, the Pix4D Matic and Pix4D Survey, those are products which are really targeted towards those kind of inspection, because they also produce a 3D model, and in that 3D model you can then click a point, you get a high resolution photo of exactly that point. So yeah, I think there are a lot of different solutions for those specific industries.
Okay, so I guess there are a couple of questions which has come, which is around one topic which I would say Julius had touched upon. Maybe because this is coming from Indian market, I guess Pradeep, if you can maybe spare some light in terms of how, if I'm a service provider, right, and I have a couple of customers as a research institute, how and I would say sell, how is it commercially viable? So there have been a couple of questions which come in around this. I would like you to maybe spare some time and please, if you could give some insights on this.
I think so. What we have is you have to get started, right? I mean, somewhere. In terms of giving services, like we mentioned already, whether it's academic or if it's specific farmers or farmer cooperations, or if there are forest departments that would like to have this kind of data, we can connect you to some of them who come to us for services, and we don't give services directly. So if you have the drone and the payload, we can route those inquiries to you, right? But in terms of what specific outputs they would want, there might be somebody who just wants a RGB map. There might be somebody who wants a NDVI map, right? So I think building that subject matter, getting the subject matter expert into the loop is very important, and getting to know what the outcome is, because most people will not just want a 2D map or a 3D model, but they will want some analytics on top of it, right? So understanding that and being close to the customer is something very important. And obviously research institutes, maybe they are developing new indices for specific crops, or using the same indices like NDVI or others, standard ones for specific crops, and looking at the life cycle of that crop. So there is a lot that can be done, but you need to have a customer connect and be close to them, be in touch with them, and try and understand, is the outcome being met or not.
Okay. So because we are heading last two, I guess we have a new question from Akshay. This is for this very specific question, I guess, regarding Pix4D mapper. Okay, I guess Julius already responded back.
So if maybe I can answer it, but I'm not sure.
Yeah, we'll what we'll do is that because we have less time, we'll wait. There is an opportunity for people to raise their hand. I guess there is the last question which we have. So if there anybody who feels that their question is not answered, probably they can raise their hand. We'll unmute you, and probably you can ask your question to either Julius or Pradeep.
Maybe I see now the question about the mapping with Mapper and the MicaSense Altum sensor. Yeah, so for that, if you don't need a 3D model, then Pix4D Fields is the way to go. So it will process this data set, what you wrote here, 100 acres, 1,200 captures. It will process it super fast. So it will take only a matter of minutes to get a a high resolution multispectral auto mosaic, and then you can do all your vegetation index analysis. So if you don't need a 3D model, Pix4D fields will crush it. Yeah, you will be happy. Yeah, even if it's 1002. Yeah, it doesn't matter. It's we handle those data sets really frequently. It is fine.
Okay. Okay, so I guess we'll try to. I guess we are almost at the end. I would want to thank you all both the speakers, right? Very specifically, Julius, uh, for spending your time and sharing your insights. And all the participants, thank you all for joining us today. There is a reminder for all of you that we will be sharing a feedback form. So if you can spare your some time and give us and rate us, and so that there is input which we'll be able to leverage for our next webinars, which will be coming soon. Uh, and we will be sharing this recording. There are a couple of questions that people did ask. So we'll be sharing this recording over email for people who have registered with us. I would say have a great evening. Enjoy your weekend.
Thank you very much for having me. Have
Thank
a good
you.
evening. Bye.
Bye.
Thank you, everyone. Bye bye.